Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Okay, in this session, we are going to study and solve some of the problems on friction. Let us recapitulate so far what we have covered before in previous sessions. We covered in previous sessions what is the friction. The friction is nothing but a frictional force. And what is the limiting types of friction? There are two types of friction. One is static, another one is dynamic. Dynamic friction is also known as kinetic friction. This dynamic friction is subcategorized into two types. Number one, sliding friction, and another one is called rolling friction. So, and another term is known as a limiting friction. Here, the limiting friction is nothing but a limiting frictional force. So, it's very, very important when limiting friction is always in the direction of the movement of the body. And in this figure, you can see the normal reaction always acts normal to the surface, not to the body. And the weight always passing through this normal reaction, and weight of the body is always passing through center of gravity of the body. And thrust and limiting friction are collinear and directional, unlike collinear forces. And here, there are different laws of the friction we have covered. And what is the normal reaction, and some of the problems we already solved in previous session. Let us begin with here one of the model we covered. So your body of the weight is 300 newtons. You're lying on your rough horizontal plane, having a coefficient of friction as 0.3. We have to find out here the magnitude of the force which can move the body while acting on an angle of 25 degrees with the horizontal. Now here the weight of the body is 300 newtons, which is acting downwards. Here we calculated the effort P. What is the effort P? That the force is 87.1 newtons. Now in this session, we are going to consider very important the model number 3, and we'll go back for model 1 and model 2. We'll revise it. Now let us begin here. Here there are two blocks A and B of weights. The weight of the block A is 1 kilonewton, and the weight of the block B is 2 kilonewtons, or in equilibrium position as shown figure. If the coefficient of friction between the two blocks as well as the block B and the floor is, that is coefficient of friction, that is mu AB equal to 0.3, and mu B and floor, that is the flat surface, that is mu BH equal to horizontal surface, that is 0.3. But we need the force P. What is the force P is required to move the body? What is the force P here? That is important here. Now how to calculate this force P or effort P? And here there is the description. If you describe this figure, the weight A is connected to a string and it is attached. One of the end is attached to a fixed to a wall, and another one is attached to A. And here the point B, here what is the coefficient of friction? Here find the force required to move the block B. What is the force required to move the block B? Under these considerations, under the weights and the coefficient of frictions between AB and between B to floor. Now here, as we considered here, the weight of the block is 2 kilonewtons. Yes, 2 kilonewtons. And the coefficient of friction is remains same between A and B and the floor. Now we considering here the weight of the block A. We are going to consider the weight of the block A. For the weight of the block A, what is the free body diagram? We have drawn the free body diagram as we discussed in previous session. What are the steps involved in solving this type of problems? What is the first step is? The first step is to draw the free body diagram. Second step is apply the equilibrium conditions. One is sigma FH equal to 0 or sigma H equal to sigma FH. Another one is sigma FV equal to 0s. Here there is no third equilibrium condition, no need to apply. Here we are going to apply only two equilibrium conditions. One is horizontal equilibrium, another one is vertical equilibrium. Alright, after that we have to find out those unknowns. Okay. Now here, important is that the free body diagram indicates there is a tension T in the string which is making 30 degrees with the horizontal. There is a normal reaction R1 upwards and 1 kilonewton vertically acting downwards. the friction force is acting, the moment here, the friction force when the block B is pushing in this downward in this direction. Okay, here the important to know is this, the tendency of the block A moves back in this direction, it moves. At that time, the friction direction of the friction force in this direction towards. Okay, you may be thinking, but on this body A, on this body B, the friction force will be in this direction. When it is in friction force, the body B is moving this direction, body A is moving, pushing in this direction, it will pull. The friction force is moving in this direction. Now, under these conditions, now here resolve this T tension. The T, that is T cos 30 and another one is T sin 30. Here, this is T cos 30 degrees and another one is T sin 30 degrees. T sin 30 and another one is T cos 30. Okay, now what is the equilibrium conditions, equilibrium equations you are following here? Horizontal equilibrium, sigma FH equal to 0. What is sigma H? You consider it. It is a positive direction and negative. Upwards positive, downwards negative. Okay, now the positive direction is T cos 30. Okay, horizontal T cos 30. And another term is minus F1 equal to 0. Then F1 equal to T times cos 30. This is the equation, one equation. Now what our next one? Equation, this F1 equal to, substitute what is F1 equal to mu times R1. So that is mu times R1 equal to T cos 30 degrees. What is the mu? 0.3 times R1 equal to T cos 30 degree. This is one relation. And I apply another equation. What is another equilibrium? Sigma FV, vertical algebraic sum of all vertical forces equal to 0. Now what are the vertical forces are? Here R1, T sin 30 and 1 kilonewton. Now the weight, that is T sin 30 plus R1 minus 1 kilonewton equal to 0. That means T sin 30 equal to 1 minus R1. That is what here, T sin 30 equal to 1 minus R1. Now T cos 30 equal to 0.3 times R1. Now from this, what is the R1 equal to? Substitute here, or you divided equation 1 by equation 2. So suppose here the equation 1, if you consider, that is T sin 30 is equation 1 and the T cos 30 is equation 2. Equation 1 by equation 2, that is T sin 30 by T cos 30 equal to 1 minus R1 by 0.3 R1. Here you cannot cancel R1, it is 1 minus R1. Now TT will be cancelled. From this, what is the R1 equal to? That 1030 equal here. Finally, what is that R1 equal to? If you resolve it here, after solving, that R1 comes as 0.85 kilonewtons. R1 equal to 0.85 kilonewtons. How did it get it here? 0.57774 equal to 1 minus R1 by 0.3 times R1. So you make it cross multiplication, that is 0.5774 times 0.3 R1 equal to 1 minus R1. Now that is 0.173 R1 equal to 1 minus R1. Then R1 plus 1.173 R1 equal to 1. Then R1 equal to 1 by 1.173, that is 0.85 kilonewtons. That is the R1. Now we know that R1 equal to, what is the R1 equal to here? Now substitute, that is F1 equal to T cos 30 equal to 0.3 times R1. From that tension comes. That is T cos 30 equal to 0.3 times R1. 0.3 times R1. From the tension comes T cos 30 equal to 0.3 times R1, that is 0.85. From the T equal to 0.3 times 0.85 by cos 30 degrees. From the tension value can be calculated. Now, what is the friction force? F1 equal to mu times R1. What is the mu? 0.3 times, is this 0.3? Yes, 0.3 times, what is that R1? 0.85. From this F1 frictional force. That frictional force 0.3 times 0.85, that is 0.225. That is 0.255. 0.255, that is kilonewtons. That is the frictional force. Now, but what is our objective? The main objective is that we have to calculate the effort, that is the P is required here. What is the P on body B? Now, next go to draw the free body diagram on body B. What is the free body diagram? We consider the block B. Now consider the block B, that here we know what are the knowns have been calculated. Very important here. Block B is considered. This is the block B. When the block B, we are moving this direction, block B is moving, pulling in this direction of the motion of the block B in this direction. Whatever friction forces on top and bottom, because the block B is in contact with the two surfaces. One is floor and another one is weight, block A. So it is the contact between floor and block A. So there are two surfaces in contact. There are two types of frictional forces. So block A and block B is in contact, that is F1. Where the P is acting in this direction, F1 moves. So similarly F2. Okay. And next, one more thing is that what about reaction force? The R1, 2 kilonewtons plus the weight of the reaction. The weight, that is R1 also there here, and R2 acts normal reaction upwards. This normal reaction R1 is between two things. One is normal reaction, the normal reaction of the weight. Here R1 is acting downwards, and also one of the R1, when we consider it, here 2 kilonewtons plus R1 is acting downward normal reaction, which acts normal to the surface. Now here. Now, what are the forces here? Again, apply the vertical equilibrium, sigma Fv equal to 0. So here, the downward force of the block A is equal to R1. Here, instead of R1, that is normal reaction, that is nothing but a weight of the block A. That weight of the block A is also acting. That is 2 kilonewtons plus, okay, the weight that is equal to downward force of the block A. What is the downward force of the block A? That is equal to R1. Okay. Now also acts along with the weight of the block B. Now apply the vertical equilibrium forces equation. Now what is the vertical? This is the force downwards, and here the force upwards. So upward forces equal to downward forces are the algebraic sum of all vertical forces equal to 0. Now R2 equal to 2kn plus R1, 2000 newtons. That is R2 equal to 2 plus R1. We know that R1 equal to, what is the R1 value? 0.85 kilonewtons. That is 2 plus 0.85, that is 2.85 kilonewtons, that is R2. What about friction force? That is mu F2 equal to mu times R2. That is mu times 0.3 times R2, 2.85, that is 0.855 kilonewtons. Now, horizontal equilibrium forces, sigma Fv equal to 0, sigma Fh equal to 0. Algebraic sum of all horizontal forces equal to 0. If you substitute here algebraic sum of all horizontal forces equal to 0, leftward forces equal to rightward forces, or the sum of both left and right equal to 0. What is the algebraic sum here? Here the algebraic sum of this, the positive direction, horizontal, the negative, that is minus P plus F1 plus F2 equal to 0. Now that equal to, from this P equal to F1 plus F2. What is the F1 value? F1 equal to, F1 value already calculated here previous, that is 0.255 kilonewtons. What about F2 here? That is 0.855. The sum is that 1.11 kilonewtons. That is the P. P equal to 1.11 kilonewtons. This is our objective. We reach here. The objective, the value is that here. The effort is required 1.11 kilonewtons. Let us go back to interpret. That P effort is required. How much effort we got it? 1.11 kilonewtons is obtained here. So the weight of the block here 1 kilonewtons and block B is 2 kilonewtons. And whatever tension we got here, the tension value is obtained here. Tension we not got, that is a tension if we applied here. What is the tension? That is 0.3 times 0.85 by cos 30. So here they did not ask what is the tension, but also can be asked what is the tension in this string between A and the wheel. Now here, when the weight is having 1 kilonewtons and the 2 kilonewtons, that means 3 kilonewtons weight is acting here. And the body to move here with the friction values we obtained is 0.3 friction between A and B and floor with 0.3. What is the force required? P. That force P is 1.11 kilonewtons is required here to move the block B. Okay, with this objective is being reached. Now, in before session here in this section, if you consider there are two cases here. Here, in this problem, your body is resting on a rough horizontal plane, required to pull off 180 newtons inclined at 30 degrees to the plane just to move it. It was found a push of 220 newtons inclined at the same angle 30 degree to the plane just to move the body. Determine the weight of the body and the coefficient of the friction. What is the weight of the bodies and the coefficient of the friction? There are two things. One is push, another one is pull. For the case 1, if you consider here 180 newtons and 30 degrees, and when you are pulling here, when you pull here, the R1 and the weight, these both are acting passing through center of gravity of the body. Then R1 is acting upwards, normal reaction, and weight is acting downwards. So if we apply equilibrium conditions here, what are the equilibrium conditions we applied here? Here 180 cos 30 and here 180 sin 30. What are the horizontal forces? Horizontally, F1 equal to 180 cos 30. What is that F1? 180 times cos 30. That is 155.9 newtons. Now what are vertical equilibrium forces? Upwards R1 positive plus 180 sin 30 minus W equal to 0. Now from this W equal to R1, if we make it R1 equal to W minus 180 sin 30. This R1 is nothing but, that is what is the W here? Weight of the body. We have to find out. What about R1? What is that R1 here? W1. What is the R1 equal to? Mu times R1 equal to, okay, F1. Here R1, we got it here. What is it? F1 from this, whatever equation, F1 equal to mu times R1. So, we know that friction force F1 equal to mu times, friction force F1 equal to mu times R1. What is the mu? Mu to be calculated. Mu times, that is what is the F1 here? 155.9 newtons equal to mu times R1. What is that R1? W minus 180 times sin 30. That is sin 30 equal to 1 by 2. That is 180 times 1 by 2. That is 90. That is mu times W minus 90. That is 155.9. That is one of the relation. The second equation is that there are two cases. No, another one is called push. The push is 220 newtons 30 degrees. Here for the case 2, the body moves towards the left direction. That's why the frictional force acts opposite to the motion of the body. That's why F2 will be in the opposite direction. Now here in this direction, that is 220 cos 30 and here 220 sin 30 degrees. Again, resolving the forces horizontally, that is F2 equal to 220 times cos 30, that's 220 times cos 30, 0.866, 190.5 newtons. Now R2 equal to whatever vertical equilibrium forces, that is R2 positive, R2 minus 220 sin 30 minus W equal to 0. From this R2 equal to W plus 220 sin 30. that is W times 220 sine 30. Again sin 30 equal to 1 by 2, that is 0.5, that is W plus 110. What is the R2 equal to? Mu times F2. R2 equal to F2 equal to mu times R2. From that relation, we got 190.5 equal to mu times W plus 110. There are two equations. One equation is this one here. Another equation is mu times. Now equation 1, divide one equation by another equation. The mu get cancelled. From that the unknown value weight comes, that is 991.2 newtons. How it comes again? Mu get cancelled. W's class multiplication, if you do, W per times 110 into 155.9 equal to W minus 90 times 190.5. Then simplification, that is 991.2 newtons. Substitute this W value in one of the equation, the mu can be obtained. What is the coefficient of friction? The obtained coefficient of friction is 0.173. Okay, 0.173 value. So, here, the W required here, how much? The W weight of the body is 991.2 newtons. And the mu, that the coefficient of friction is 0.173. Now, the second case we are going for next model. So far we covered in this previous sessions and in this up to so far till now, we calculated only horizontal planes. When the body is in a horizontal plane, what is the weight? Weight of the body calculated, and also coefficient of frictions. The value of the coefficient of friction is also calculated for the case of a horizontal plane. Now we are going to study how to calculate the normal reactions or coefficient of frictions or weight, unknown values or effort values on an inclined plane. Let us begin. Here we are going to consider a rough inclined plane. It is not a smooth inclined plane. Why rough inclined plane here? The term used, a rough inclined plane, means coefficient of friction exists. If it is smooth inclined plane, there is no coefficient of friction. Now here on a rough plane, to a force acting along the inclined plane. The force acting along the inclined plane, there are two cases we are going to study. The force can be acted along the inclined plane. Okay. The force can be acted in what direction? Upward. One case is that upward. The body moves upward direction. Okay, when the body moves upward direction, what is the coefficient of friction? The direction of the force. Okay, or the body, even though parallel to that force is acting, but the even though the effort is kept like that P1, but the body is moving downwards. When the body is moving downwards, whatever friction force which acts upwards. When the body goes upward, whatever friction force acts opposite to the direction of the motion of the body, that is in downwards. Now here, we are going to study, there are two cases. Case 1. Here the minimum force P1, which will keep the body in equilibrium when it is at the point of sliding downwards. The point of sliding downwards. Under this case, when the body is sliding downwards, the direction of the friction force, the direction of sliding bodies are coming down. What is the direction of friction force? It acts opposite to the direction, opposite to that. So that the F1 is acting upwards. The normal reaction is always normal to the surface, normal to the inclined plane. Here, this is the normal reaction, where R1 is the normal reaction. And weight always acts vertically downwards, passing through center of gravity of the body. Now the weight W is acting downwards, which is acting, yes. Now what is the angle? The angle between the normal to the plane and the angle of the direction of the weight of the weight line passing through the weight. That angle is equal to, same as the angle of inclination, that is alpha. Now the direction of the P1, effort is P1. Now we have to resolve these components, the W along the plane and normal to the plane. Now here it is along the plane, it becomes W cos alpha, and parallel to the plane, normal to the plane is W cos alpha, and the parallel to the plane becomes W sine alpha. Now we are going to apply the equilibrium conditions parallel to the plane and normal to the plane. The parallel to the plane, if you consider the parallel to the plane, you can consider either upwards is positive, downwards is negative, normal upwards is positive, downwards negative. This is inclined plane, the direction of. Now, how to make it here? Another one, whatever, this is also alpha. So it is already normal to the direction, no need to make it here with this only normal direction. Now what are the forces? P1 plus F1 equal to 0. That P1 equal to minus F1. That is minus mu times R1. That is the P1 value. Whatever next value, the normal, it is the direction parallel to the plane. Parallel to plane. Inclined plane. Whatever normal to the plane, if you resolve the component normal to the plane, what is the normal direction? Yes, no, here. Not only F1, P1, there is one more force is there. What is that one more force? Minus W times sine alpha. Here, wait. That means P plus F1 what will happen this equation? Wait. Yes, P plus F1 in the same direction minus W sine alpha equal to 0. That P1 equal to W sine alpha minus F1. This is the equation. Okay, that to be minimum force. What is F1? What is another one? How we need F1 equal to mu times R1. That R1 can be calculated. How to out1? That R1 is of course R1 sigma FV normal to the plane. R1 minus W cos alpha equal to 0. That R1 equal to W times cos alpha. And F1 equal to P1 equal to W sin alpha minus whatever F1 mu times R1. That is mu times W cos alpha. Now thus we will going to make it systematically. How it comes? Let us begin. Okay. What is that? We calculated mu W sin alpha minus mu times W cos alpha. W times sin alpha minus mu cos alpha. This is what we calculated. How we calculated? Along the plane. P1 equal to W sin alpha minus mu R1. Now resolving the forces as you follow this method as I mentioned here. That is what equation. How we calculated here, it comes along the plane perpendicular to the plane. One is P1 equal to W sin alpha minus mu R1. Now R1 equal to W cos alpha. That is P1 equal to W sin alpha minus W times sin alpha minus mu cos alpha. Now we know that mu equal to tan phi. That is the coefficient of friction. The tan phi mu equal to tan phi. If you substitute here, P1 equal to W times sin alpha minus tan phi cos alpha. Now, if you make it, yes, tan phi equal to sin phi by cos phi. And after doing LCM and all, what will happen? P1 cos phi equal to W times sin alpha cos phi minus sin phi cos alpha. That is sin A cos B minus cos A sin B. That is sin of, okay, that is sin of A minus B. That is W times sin alpha minus phi. So P1 equal to P1 cos phi equal to this value. P1 equal to W times sin alpha minus phi by cos phi. What about phi here? The angle of friction. What about alpha? The angle of inclination of the plane, where W is the weight of the body. This P1 is the minimum force here. What is the P1 here? The P1 is calculated here. What is the P1? P1 is minimum force. That is the P1. The next case, we are considering maximum force. Maximum force when it is required. Maximum force required when the body moves upwards. Here, the plane is moving upwards. Then what about friction force? It acts downwards. That's why we consider here downward direction. F2 equal to mu times R2. I'm going to derive the expression, the maximum force expression here itself. Now, this is along the plane W cos alpha and here along the plane, normal to the plane is W cos alpha, and here it is W sin alpha. Now equation 1, along the plane calculation, P2 minus F2 minus W sin alpha equal to 0. That is P2 equal to F2 plus W sin alpha. Okay. What about F2 equal to mu times R2 plus W sin alpha? That is P2. What about mu? Tan phi. Tan phi times R2 plus W sin alpha. That is P2. But we need R2. R2 comes from the reactions applying equilibrium conditions resolving normal to the plane. Normal to inclined plane, that is R2 equal to W cos alpha. R2 equal to W cos alpha. Substitute this R2 in the equation of P2, then what happens? Tan phi times, what about R2? W cos alpha plus W sin alpha. Now tan phi equal to sin phi by cos phi. W make it common, then W cos alpha, okay, plus what will happen here? W sin alpha. You make it LCM, what will happen here? Sin phi by cos phi, here cos phi and sin alpha. Sin alpha, cos alpha, and cos sin phi cos alpha plus cos phi sin alpha. That is sin of alpha plus phi. So finally what will happen here? That is P2 equal to W times sin of alpha plus phi by cos phi. That's what it comes. Okay. That is P2 equal to same thing. Please follow the steps you followed here. Then after that go through what we made it here, the notes. Along the direction parallel to the plane, resolve parallel to the plane, equilibrium condition parallel to the plane. That is P2 equal to W sin alpha plus mu times R2. Then apply resolving the forces perpendicular to the plane. That is R2 equal to W cos alpha. This R2 here substitute, and mu equal to, that is P2 equal to W times sin alpha plus mu cos alpha. And what is the mu equal to? The coefficient of friction, mu equal to tan phi. The tan phi equal to sin phi by cos phi. Then after doing LCM, then you make it, then P2 equal to W times sin alpha plus phi by cos phi. Okay. Now here, this is what we have studied here. In this session, we covered two things. One, we considered here very important. There are two problems we solved here. What are the two problems are? One is the multiple body problem. Another one is a single body problem. And finally, when your body, a single body is on inclined plane, then how to calculate the effort, minimum force and maximum force. Now here, the P1, the P2 is the maximum force. The P2 is the maximum, that P2 equal to W times sin alpha plus phi by cos phi. And what about minimum force? That minimum force of P1 equal to W times sin alpha minus phi by cos phi. The minimum force and maximum force, if we observe the derived expressions, the difference is that here the minimum sin alpha times minus phi, whereas maximum sin alpha plus phi. So P1 equal to, this is the value, what about P2 equal to W times sin alpha plus phi by cos phi. What about P2 equal to W times sin alpha plus phi by cos phi. This is the P2 is the maximum force and P1 is the minimum force. So this minimum force came when the body is sliding downwards. It is easy to move. Minimum force is required for sliding, because by gravitation, by sliding, it slides down. But maximum force is required when you're going in upper direction and the body pulls. Okay, pulling required here on inclined plane. On inclined plane, the maximum force, the maximum effort is required. This is the only condition for what? Inclined plane. Whereas for horizontal plane, okay, pulling is required, less effort than pushing. Okay, there it is. So with this, we can wind up the session. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.